According to the National Electrical Code, a readily accessible disconnect must be provided for all air handling equipment. This requirement ensures that the equipment can be easily de-energized for maintenance or in case of an emergency. The question arises whether a 15-amp single-pole switch, similar to those used in furnace applications, can serve as the disconnect for a 120 volts air handler or remote air conditioning unit. Furthermore, it's important to determine if a separate disconnect is necessary if the electrical panel is within sight of the unit. The answer lies in understanding the specific stipulations outlined in the National Electrical Code and considering the accessibility of the electrical panel. If the electrical panel is within sight of the unit and is easily accessible, a single-pole 15-amp switch mounted directly to the unit may be acceptable as the disconnect. The key factor here is accessibility. The National Electrical Code emphasizes the importance of being able to quickly and safely shut off power to the equipment. When the panel is close by and unobstructed, a switch on the unit can provide that functionality. However, the situation changes if the electrical panel is not within sight of the unit or if it is not easily accessible. In such cases, the National Electrical Code mandates that a separate disconnect must be installed near the unit. This separate disconnect ensures that there is a readily available means to de-energize the air handling equipment, regardless of the panel's location or accessibility. Accessibility is a crucial concept in electrical safety and code compliance. It refers to the ability to reach an operated device or component without obstruction or difficulty. For example, if an electrical panel is located behind a locked door, in a cluttered storage area, or high up on a wall, it would not be considered easily accessible. In these situations, relying solely on the main panel disconnect would be insufficient, and a local disconnect switch near the air handler would be required. The size of the disconnect, in this case a 15-amp single-pole switch, must also be appropriate for the electrical load of the air handler. The switch must be rated to handle the voltage and current requirements of the equipment. Using an undersized switch could lead to overheating, failure, and potentially a fire hazard. To determine the correct size of the disconnect, refer to the air handler's nameplate, which lists its electrical specifications, including voltage, current, and maximum overcurrent protection. It is important to note that electrical codes and regulations can vary depending on the local jurisdiction. What is permitted in one area may not be allowed in another. Therefore, it is always essential to consult the specific requirements of the local electrical code and obtain any necessary permits before installing or modifying electrical equipment. Furthermore, working with electricity can be dangerous, and it is always recommended to consult with a qualified electrician for guidance on the appropriate disconnect device and its installation. A licensed electrician has the knowledge, skills, and experience to ensure that the electrical work is performed safely, correctly, and in compliance with all applicable codes and regulations. The electrician can assess the specific circumstances of the installation, consider the local code requirements, and recommend the best solution for providing a readily accessible disconnect for the air handling equipment. They can also properly size the disconnect switch, ensure that it is correctly installed, and verify that the entire electrical system is safe and functioning properly. In summary, when determining whether a 15-amp single-pole switch mounted to the unit is sufficient as a disconnect for a 120 volts air handler, consider these points. Firstly, the National Electrical Code requires a readily accessible disconnect for all air handling equipment. Secondly, if the panel is within sight and easily accessible, a single-pole 15-amp switch and the unit may be acceptable. Thirdly, if the panel is not within sight or easily accessible, a separate disconnect near the unit is required. Fourthly, consult the local electrical code and a qualified electrician for guidance and to ensure compliance. Safety should always be the top priority when working with electricity. By understanding the National Electrical Code requirements, considering the accessibility of the electrical panel, and seeking expert advice, you can ensure that the air handling equipment has a safe and compliant disconnect. The specific section of the National Electrical Code that addresses disconnects for air conditioning and refrigeration equipment is Article 440.14. This article outlines the requirements for disconnecting means and their location, ensuring that service personnel can safely de-energize the equipment for maintenance or repair. Article 440.14 specifies that a disconnecting means shall be located within sight from and readily accessible from the air conditioning or refrigerating equipment. The term within sight means that the disconnect is visible from the equipment and is not more than 50 feet away. Readily accessible means that the disconnect is capable of being reached quickly for operation without requiring to climb over or remove obstacles. There are exceptions to the within sight requirement, such as when the disconnecting means is capable of being locked in the open position and the location of the disconnecting means is permanently marked in the equipment. This allows for situations where the disconnect may be located remotely but can be secured to prevent accidental re-energization. In the context of a 120 volts air handler or remote air conditioning unit, the considerations for the disconnect are the same. The disconnect must be readily accessible and within sight of the unit. If the electrical panel serving the unit is within sight and readily accessible, the breaker in the panel can serve as the disconnecting means, provided it meets the requirements of Article 440.14. However, if the panel is not within sight or readily accessible, a separate disconnect switch must be installed near the unit. A 15-amp single-pole switch mounted to the unit may be acceptable as the disconnect, but it must be properly rated for the voltage and current requirements of the air handler. The switch must be listed and labeled for the intended use and must be installed in accordance with the National Electrical Code and the manufacturer's instructions. It is also important to consider the interrupting rating of the switch. The interrupting rating is the maximum fault current that the switch can safely interrupt. The interrupting rating must be equal to or greater than the available fault current at the point of installation. The available fault current can be determined by performing a fault current calculation or by consulting with the local utility company. In addition to the National Electrical Code, local codes and regulations may have additional requirements for disconnects. It is important to check with the local electrical inspector or building department to ensure compliance with all applicable codes. Furthermore, it is recommended to consult with a qualified electrician for guidance on the appropriate disconnect device and its installation. An electrician can assess the specific circumstances of the installation and ensure that the disconnect is properly sized, installed, and connected. In conclusion, the requirements for disconnects for air conditioning and refrigeration equipment are outlined in Article 440.14 of the National Electrical Code. The disconnect must be readily accessible and within sight of the unit. If the electrical panel is not within sight or readily accessible, a separate disconnect switch must be installed near the unit. A 15-amp single-pole switch mounted to the unit may be acceptable as the disconnect, but it must be properly rated and installed. Always consult with a qualified electrician and check local codes to ensure compliance. When considering the installation of a disconnect switch for an air handler, it is important to understand the different types of switches available and their suitability for the application. Firstly, single-pole switches are commonly used for controlling lighting circuits and other basic electrical loads. They have two terminals and simply open or close a single circuit. Secondly, double-pole switches have four terminals and can control two separate circuits simultaneously. They are often used for switching both the hot and neutral conductors of a circuit. Thirdly, fuse disconnect switches incorporate a fuse into the switch mechanism, providing overcurrent protection in addition to the disconnecting function. These switches are typically used for larger loads and provide an extra layer of safety. Fourthly, non-fused disconnect switches simply provide a means of disconnecting the power to the equipment without any overcurrent protection. These switches are often used in conjunction with a separate circuit breaker or fuse panel. For a 120 volts air handler, a single-pole switch may be sufficient, provided it is properly rated for the voltage and current requirements of the unit. The switch must be listed and labeled for the intended use and must be installed in accordance with the National Electrical Code and the manufacturer's instructions. However, it is important to consider the potential benefits of using a double-pole switch or a fuse disconnect switch. A double-pole switch can provide an extra measure of safety by disconnecting both the hot and neutral conductors of the circuit. This can help to prevent accidental shocks or electrical faults. A fused disconnect switch can provide overcurrent protection in addition to the disconnecting function. This can help to protect the air handler from damage due to overloads or short circuits. When selecting a disconnect switch, it is important to consider the amperage rating of the switch. The amperage rating must be equal to or greater than the maximum current that the air handler is expected to draw. The maximum current can be found on the air handler's nameplate. It is also important to consider the voltage rating of the switch. The voltage rating must be equal to or greater than the voltage of the circuit. In this case, the voltage is 120 volts. In addition to the electrical considerations, it is also important to consider the physical location of the disconnect switch. The switch must be readily accessible and within sight of the air handler. This means that the switch must be easily reachable and visible from the air handler without having to climb over or remove any obstacles. If the electrical panel is not within sight or readily accessible, a separate disconnect switch must be installed near the air handler. The National Electrical Code provides specific guidelines for the location of disconnect switches. It is important to consult the National Electrical Code and the local electrical code to ensure compliance with all applicable requirements. Finally, it is always recommended to consult with a qualified electrician for guidance on the appropriate disconnect device and its installation. An electrician can assess the specific circumstances of the installation and ensure that the disconnect is properly sized, installed, and connected. The electrician can also verify that the entire electrical system is safe and functioning properly. In summary, when selecting a disconnect switch for an air handler, consider these points. Firstly, choose the appropriate type of switch, such as a single pole, double pole, or fused disconnect switch. Secondly, select a switch with the correct amperage and voltage ratings. Thirdly, ensure that the switch is readily accessible and within sight of the air handler. Fourthly, consult the National Electrical Code and the local electrical code for specific requirements. Fifthly, consult with a qualified electrician for guidance and to ensure compliance. When installing a disconnect switch for an air handler, it is important to follow all safety precautions and to comply with all applicable codes and regulations. Firstly, always disconnect the power to the circuit before working on any electrical equipment. Secondly, use properly insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. Thirdly, follow the manufacturer's instructions for installing the disconnect switch. Fourthly, ensure that all connections are tight and secure. Fifthly, test the disconnect switch after installation to verify that it is functioning properly. Sixthly, label the disconnect switch to indicate the equipment that it controls. Seventhly, keep the area around the disconnect switch clear and free of obstruction. The National Electrical Code provides detailed instructions for the installation of disconnect switches. It is important to consult the National Electrical Code and the local electrical code to ensure compliance with all applicable requirements. Furthermore, it is always recommended to consult with a qualified electrician for guidance on the proper installation of a disconnect switch. An electrician can assess the specific circumstances of the installation and ensure that the disconnect is properly installed and connected. The electrician can also verify that the entire electrical system is safe and functioning properly. In addition to the installation requirements, it is also important to consider the maintenance of disconnect switches. Disconnect switches should be inspected regularly to ensure that they are functioning properly. The contact should be clean and free of corrosion. The switch should operate smoothly and without any binding or sticking. If any problems are detected, the disconnect switch should be repaired or replaced immediately. Regular maintenance can help to ensure that disconnect switches function properly and provide reliable protection against electrical hazards. It is also important to keep the area around the disconnect switch clean and free of debris. This can help to prevent the switch from overheating and can also make it easier to access the switch in case of an emergency. In summary, when installing and maintaining disconnect switches, consider these points. Firstly, follow all safety precautions and comply with all applicable codes and regulations. Secondly, use properly insulated tools and wear appropriate personal protective equipment. Thirdly, follow the manufacturer's instructions for installing the disconnect switch. Fourthly, ensure that all connections are tight and secure. Fifthly, test the disconnect switch after installation to verify that it is functioning properly. Sixthly, label the disconnect switch to indicate the equipment that it controls. Seventhly, keep the area around the disconnect switch clear and free of obstructions. Eighthly, inspect the disconnect switch regularly and repair or replace it if necessary. Ninthly, consult with a qualified electrician for guidance and to ensure compliance.